to the definite interval idea in a moment. Okay, so we're looking at the top half of the circle. We're working with the top half. So you want to draw the top half of a circle that has a center of -2, +4, and a radius of 3. So as best you can, sketch that idea. Okay. Now, again, when we are working with your definite integral, okay, you're finding the area under the curve. That means that we're finding the area under the curve between the function and the entire x-axis. So this is not just going to be top half of a circle. You're going to just have to add a rectangular region on. Okay, so we are integrating in this case from -5 to +1. I didn't draw my radius very well, but that's okay. Okay, so we do have the top half of the circle. We'll find the area of that. Okay, but to get all the way to the curve, you also have this rectangular region in here. So we'll have to add those two areas together. Make sense? Yeah.
How do we know it's not just...
That's the definition of your definite integral. It's area under the curve. So it's always the area between the function and the x-axis.
Okay, and in that case, in the last case, since it was on the, we didn't have to account for that because it was on the orange.
Right.
Oh, and the 0.
Okay. So obviously we have two different regions. I would give them some sort of label. So I'm going to call my circle region, semicircle region A, and I'll work with the region B. Okay. So region A, the area for region A, which is a semicircle. Okay, you're going to work with half of the area of the circle. Okay, so the formula in this case would be 1/2 times pi times what squared? What's our radius?
3.
Okay. So we end up with an area of 9/2 pi. Okay, what's the area of region B? It's a rectangle. Area of region B, length times width. What's the length?
6.
Width.
4.
So what's the area?
24.
24. Okay, now,
I just thought
get used to giving an exact answer. Okay, so we're talking about area under the curve, the definite integral value of the original function, -5 to 1 of 4, plus the square root of 9 minus the quantity x plus 2 squared with respect to x is, doesn't matter what order you add them, 24 plus 9/2 pi. Just leave it an exact answer. Don't even go to the decimal world. Just stay there.
Can we just say f of x when we're writing it down? Test this.
Yeah. Yeah, since f of x is defined. Would it make you happier if I did that?
I just wanted to know if we're testing for the right
Any questions? What do you think? Yeah.
When we write our answer, should we rewrite the question?
You would want to indicate the value of the definite interval.
Okay.
Okay. Okay. 7. Now let's get the mean value here.
What happened to the smart board?
Oh, yeah.
Did you...
Well, to be completely honest, when they updated to, they always give it an animal name.
Lion?
I was thinking cougar or whatever. When they updated, it no longer interfaced with our whiteboards.
Oh.
What?
Gosh.
They may have now, but it was like, that all happened just like 2 days before school started.
Maybe I can't get 13.
What?
Yeah,
Get
some
13.
smart boards you can. There's a regular mark on it. These are Keynote boards, so.
Oh, on
They're
the other
there
one.
for no reason.
Go back.
Don't even get me started.
Forward. Go forward.
13?
Okay. Mean value theorem for integration. We also have what's called the average value. This is all on page 278 in your book. You can look at the proofs of it, 278, 279, and list all like the reasons why.
Take a look at it.
Okay, but if a function f of x says is continuous on an interval from a to b, okay, then there exists a value c, between the values a and b, such that the following is true. b minus a times f of c is equal to the definite integral value of f of x with respect to x. Okay, so there's a lot of notation there. Let's take the visual approach again. I need to kind of explain some things. Because basically what you end up with is a rectangle that has the exact same area as the area under the curve. That's really what it's simply saying, okay? Let's draw a makeup function. Let's draw a made-up function. Give yourself an y-axis a little hard. Just for the sake of being able to talk about it, why don't you try and sketch the same thing I'm sketching?
Oh, gosh.
You can make the sound. Woo!
Hooray.
Okay, so just got this random function, f of x, okay, and it's continuous on the interval from a to b. What we're this is simply saying, the mean value theorem says that there's a value somewhere between a and b, okay, which is c, in which the area of the rectangular region, b minus a times c, this point right here, f of c,
Does it matter where C
equal to
is?
the area.
Oops.
In this case, you'll see if you read the book, just like we use rectangles to underestimate and overestimate, okay, in this case, the rectangle could be within the region or outside of the region, okay, the average value, okay? So just breaking this down, okay, we know that a to b of f of x dx, we're talking about area between the function and the x-axis. The mean value theorem simply says that there's a value between a and b such that the value of the function f of c, this point right here would be c f of c, okay, so the area of this rectangular region would actually be equal to the area under the curve.
C or C F.
C f of c. Okay? So we're saying the area of this rectangular region, b minus a, is the actual width of the rectangle, times the height, f of c, the area of that rectangular region is the exact area under the curve. That's simply what it's saying. Okay?
I just lost you.
Now, the value of f of c given in the mean value theorem, okay, the value of f of c is simply called the average value.
Area she's highlighted is equal to this area.
We're going to find the mean value, and we'll also find the average value. Okay, the mean value and the average value. Okay, so maybe just kind of make a note to yourself, right here in this place, okay, the area of the rectangle. The area of the rectangle is equal to what?
Area of the curve.
Is equal to the area of the curve. Okay, so you can have c is an x value, okay, f of c is the height of the function. Okay, is everybody got that written down? Alright, so, number one, we want to find the value of f of c guaranteed by the MVT. What does that stand for? Mean value theorem, for integration, for the function
My
that is
virtual
graphed
turtle.
for you.
Oh, it's ridiculously close.
Now, I'm just going to kind of rewrite that information over here off to the side. We have b minus a times f of c is equal to the definite integral value from a to b of f of x with respect to x. Okay? So let's just plug in the values that we have in this problem. We're working on the interval from 1 to 4. Okay, we're looking at the interval from 1 to 4. So that's the value of b minus a. So we got 4 minus 1 times f of c. We're going to figure out what that is in a moment. Okay. This is equal to the definite integral value from 1 to 4 of the function x cubed minus 4x squared plus 3x plus 4. Okay, so I'll just plug in things. What is 4 minus 1, by the way?
3.
Okay. So, what do you think you're going to need to do? Get the definite integral value. can do that. Integrate that.
I don't want to.
Integrate. What's the integral of x cubed? Anyone? 1/4 x
The
to
four.
the fourth minus 4x squared would be, or there's x cubed,
Plus 3 times x squared.
3 times x squared, plus 4x. And we are integrating from what to what? 1 to 4. Okay?